Today it's our 11th video on graph theory, which is on single source shortest path Dijkstra algorithm. So prior to this, in video number 10, we have solved the question of single source shortest path using Dijkstra algorithm. So I'll again say that I'm following reverse engineering, where I'm discussing question first and then algorithm, because if we solve question using algorithm and then you study algorithm, it will become easy for you to understand algorithm. So let's start with the Dijkstra algorithm. So first you have Dijkstra algorithm. That is Dijkstra algorithm. Graph is given to you, weight is given to you, and S source is given to you. That is from where you have to start. Dijkstra is all about single source shortest path. Dijkstra algorithm is single source shortest path. I request you to kindly watch video number 10 so that it will become easy for you to understand. Now, first step of either you say Prims or now even Dijkstra is initialize single source. Initialize single source means we initialize source with 0 and all other node with infinite. Hope you remember, which we have already discussed in Prims. Now, and we have already discussed in Dijkstra question. Now you have to make a set and initialize it with 5. That is, set is containing nothing. Then initialize Q with all the vertex of graph. That is, Q is having a Q data structure is having all the vertex of graph. Now, while Q is not empty, so what is initialize single source? Just see. So initialize single source, till here we have discussed, but again I'm telling you what is initialize single source means, where for every vertex of graph, for every vertex belong to graph, do key u infinity. Means suppose you have a graph, now I'm taking this graph. See, so I've initialized all the vertex. First of all the vertex with infinity, infinite. Then what I did, pi u is equal to nil, means I don't know, I don't have any knowledge about the parent of any node. I don't know who will be the parent of B, I don't know who will be the parent of D. So I have initialized parent of every node, every u which is part of VG with nil. Now key source. So what is source? From where you have to start with 0. So because of this, I have taken this source as 0. Fine. Okay. Now, so this is called initialize single source. Then second you have created a set. Suppose I'm creating a set over here S, and I'm initializing it with 5. Suppose I'm initializing it with 5. That is, there is nothing in the set. Now I have made a Q. See, you can see a Q data structure, and I've inserted all the vertex of graph. How many vertex are there? 5. A, B, C, D, E. I've initialized all the vertex. Now, while Q is not empty, till the Q is not empty, what do? Do extract minimum Q. So how many element you have to extract? All the element of a Q. So therefore we have taken 1, 2, 3, 4, 5 extract minimum Q. This means 5 rows for each vertex. Fine. So now let's start with algorithm. Do extract minimum Q in U. So what is minimum Q? At first step you will see node A is 0, all other are infinity. So what is that U? U is A, because A is minimum. So you will extract A here. So what is there in U? A. Fine. So I'll explain you the algorithm. So A, you have no dq the element which is minimum, that is A. Now what? You add this element to S, that is add S union U. What is U? A. So I will add A to this set S. Now what? For each vertex V, very important, for each vertex V which is adjacent to U. What is U? This is U. So all those vertex which are adjacent to U, what are those vertex? Adjacent are, first is B and next is C. Fine. So C and B are adjacent to what? C and B are, so this V is V, all those V which are adjacent to U. What is U? U is A. So all those vertex which are adjacent to A are C and B. Fine. Okay. Now you have to relax. I have already explained you what is relax. So do relax. So what is relax? The algorithm of relax is, if you have given U, suppose now I'm taking U, U is what? A. You have 2V. Let consider B as first V. So B, and what is W? What is W? A, distance between A and B. So distance between A and B is 10. So it is 10. Now see, if dv, what is dv? What is v? W b. What is db? Db is what? Infinity. Is db greater than du? What is du? 0. So I put 0 over here, plus wuv. What is wab? 10. So 0 plus 10 is what is dv? dv is infinity. Is infinity dv? What is v? b. So it's is db is greater than 0 plus 10. Yes, infinity is greater than. So what you do? You relax. What you do? You add the sum and change it with infinity. So what? Initialize dv with this sum. So 0 plus 10 will be 10. So again I am saying, kindly watch the question. Kindly watch the question 10th video first. Fine. So this will become 10. Now pi v is equal to u. Who will be the parent of v? What is v? B. Now a will be the parent of b because a identified b. Now fine. Okay. So this was the first part. Is my job is over? No. For each vertex adjacent to v adjacent to a. So what is next vertex? C. So now I'm considering c. So I'm calling relax. What is u? A. But now v is c. And what is distance between a and c? 3. Now again c. It's db. What is v? C. It's dc. dc is what? Infinity. Is dc is greater than du? What is du? 0. And wuv is 3. 0 plus 3. Yes, infinity is greater. So again assign this sum to this. So I'll cancel this and I'll assign this 3 to here. Fine. Now pi v. So parent of this will become this. Fine. So this will become this. So again what I'll do, is my job over? No. What changes took place? The changes took place. B become 10. You write 10 over here, and what become C become 3. Now again extract minimum. So you will keep, is Q empty now? No, we still have many element B, C, D and E. Now extract minimum. What is minimum? Now we have minimum C. So I'll extract C. Fine. So I've taken out C. Add this. The next step is saying what? Add this element to S. So now this S will have C. Fine. Okay. Then for each vertex V belong to adjacent to adjacent to C. So what are those nodes which are adjacent to C? So the nodes which are adjacent to C are B. The node which are adjacent to C are B. Fine. And then E, and D. Now you will relax all vertex from CB, all vertex CB, CE, CED. Fine. So this is what you will keep on relaxing. Fine. So this is what you will keep on doing, and this will make your algorithm run, and finally you will get a shortest path, that is single source shortest path. What is single source? That you are calculating. What is single source? That you are calculating shortest distance from A to B, shortest distance from A to D, shortest distance from A to E, shortest distance from A to C. So what is common? A. That is single source. That is source is single, and you have to find shortest path from this source to all other nodes. Because of this is called single source shortest path. Fine. So the algorithm is, so this was all about the algorithm. You just trace the algorithm. I'll not keep on tracing because I've already discussed in video number 10 how to solve the question of Dijkstra. Fine. I've already traced everything. So I request you again, if you're watching this video, kindly watch video number 10 first.